Today we have an episode on network security and DDoS attacks mitigation. More specifically, we'll talk about BGP Flowspec on NCS 5500 and integration with Arbor Networks solution. More after the break. We will split this video in two parts. First, we will talk about BGP Flowspec principles and how we configure it on IOSXR. In the second part, we'll run a demo with a MemCacheD amplification attack. It will be detected and auto-mitigated with a solution composed of an NCS 5500 on one side and an Arbor Networks SP on the other side. But let's start with a few words on BGP Flowspec. If you want more details on the technology, I will let you watch the Cisco Live session presented in Las Vegas in early 2018. It contains all the details you need to understand our implementation. To summarize what BGP Flowspec is and can do, I will say it's a mechanism used to influence remotely the forwarding plane of a routing device. It has been ratified in 2009 with 2 RFCs, and for once it's an easy read. In this case, BGP is used to transport what we call rules between a controller and clients. These rules are made of 2 elements. A description, that's a field coming from the layer 3 and layer 4 IP headers that we will use to identify specific packets. For example, address and port, source and destination for UDP and TCP, ICMP type and code, but also TCP flags like SYN, ACK, reset, packet length, DSCP field, and fragment indicators. The second element is an action. It describes the treatment of the packet matching the former description. We can rate limit or drop a flow, we can divert the flow to a specific address or a different VRF, and we can remark the DSCP value. In a BGP Flowspec architecture, we have a controller or server. It contains a control plane where will be originated the rules. It's basically the brain of the solution. Second, we have the client. It does have a control plane too to receive the rules, but also it contains a forwarding plane part to program the hardware. The client is the muscle here. It will influence the traffic based on the controller's recommendation. Optionally, it's possible to use a route reflector for better scalability when you have a lot of clients. Something important to mention. By nature, BGP Flowspec is unidirectional. That means there is no feedback loop providing information on the impact of the rules you applied on interfaces. Nothing in the protocol will send details on the number of packets that have been matched and dropped by the rules. This information must be collected via different tools. Flowspec is commonly used inside a given autonomous system, but as the name implies, it's BGP-based, and therefore the common propagation rules for internal and external BGP will apply. But in real world, we see very few cases for inter-AS usage of Flowspec. Before we move to the configuration, I need to mention a feature which will simplify your designs significantly. Packets targeted to 10.0.16.51 are flowing from left to right following the best route available in the read, /20. A BGP Flowspec controller injects the rules diverting the traffic targeted to the same /20 to another device. The Flowspec rule will take precedence over the routing, and the packets are diverted to A. If A is a system on a stick, like a DPI appliance or a DDoS scrubbing device, the packets are stuck in a routing loop until we reach a TTL limit, and we drop them. Several routing tricks based on VRF Lite exist to address such a situation, but now we have a much more elegant solution. This IOSXR implementation gives the flexibility to decide which interfaces are enabled or disabled for Flowspec. So, if you disable it for this interface facing device A, when the packets are coming back, we don't use Flowspec, but the natural route to B, and we bypass the routing loop. Okay, now you understand the basic principles of BGP Flowspec, let's check the configuration. The controller device is the Arbor Network SP. The client is an NCS55A1 36H It's a one IO system based on Jericho Plus and external TCAM running IOSXR 651. The attack traffic will be received on 10 gig interface 0000. IPFix is configured with a sampling interval of 1 for 1000. The monitor map defines a cache of 1 million entries and an active timeout of 10 seconds. We see here the export map is indeed configured for IPFix, and we verify that our configuration is applied and operational. Now, let's take a quick look at the BGP configuration part. Here, the neighbor address represents our Arbor network controller, and we simply need to position an address family's Flowspec at the router level and below the neighbor statement. Finally, under the Flowspec part, we see it's applied to all interfaces. And that's it. Nothing more is needed on the router, and we are now ready for the demo. In the next video, we will show you how NCS5500 can interoperate with Arbor Network Solution. We will mitigate automatically a MemCacheD attack, and we will demonstrate it's not necessary to perform deep packet inspection for this kind of attack. It can be addressed very efficiently with BGP Flowspec. Thanks for watching. See you very soon in the next video. Hey, this is the second part of our video on BGP Flowspec with NCS5500. Today we will see the interaction with Arbor networks and how we can automatically tackle a MemCacheD, an NTP and a TCP SYN flood attack. In the former video, we presented the Flowspec protocol and how we can configure it on IOSXR. For more config examples, I invite you to take a look at the support forum post Yosef published. The link is available in the description. Now, let's talk about one of the attacks we will handle today, the MemCacheD amplification attack. It has been popularized in early 2018, and this Arbor page is a very good starting point. You can see, for example, that it is based on UDP 11211, but you will find many more details in this article. On this Cloudflare website, they provide details on the different steps used to build a MemCacheD amplification. Also, on this other site, they compare the amplification factor for most of the common DDoS attacks. You can see MemCacheD is by far the biggest. The last resource I recommend is the Shadow server website. They are scanning the internet on a daily basis to identify how many systems are vulnerable to amplification attacks. You can see 35,000 devices that can be used to create a MemCacheD attacks today. We note a drop in March 18, but since that time, the number is decreasing very slowly. That means MemCacheD attacks are here to stay. The good news for network operators is that BGP Flowspec is a perfect tool to tackle amplification attacks at the border of the network. We will demonstrate it today with our partner Arbor Network. Their SP system is able to detect these attacks and trigger auto-mitigation with Flowspec. Now, let's check our testbed. We are using an NCS55A1 36H SCS. It's a system based on a Jericho Plus ASIC with external TCAM. You can see we have our BGP and BGP Flowspec sessions up, but no route or rule are received at the moment. The route to reach the victim is a static /24. During this demo, we'll use three different attack vectors. First, a MemCacheD amplification. Second, an NTP amplification, and last, a TCP SYN flood. The first two can be handled on the router with Flowspec. The last one will require a more advanced system to challenge the TCP traffic and differentiate the malicious packets from the legitimate sessions. We start checking the Arbor GUI and we verify we don't have any current ongoing alert. It's all clean. We now launch the MemCacheD attack from the traffic generator. On the NCS5500, we check IPFix, and we quickly see that indeed we have entries for UDP 11211 with fairly large packet size. back to the SP GUI. An alert has been created for this attack, and the Flowspec automitigation has been triggered. With show BGP IPv4 Flowspec, we verify that a rule has been received on the router for protocol 17, that's UDP, and source port 11211. And with show Flowspec HAFI all details, we see we are indeed matching and dropping packets. We click on alert 3034 and we verify the attack packets are still seen even if they are dropped by the Flowspec mitigation. It's important to keep this visibility. It permits to know if the attack is ongoing or stopped. Now we can start a second attack vector. This time we simulate an NTP amplification. That translates in abnormally large NTP packets targeted to the victim. IPFix is sampling these streams, and now we have UDP 123 in the cache, still with MemCacheD entries. Automatically, the mitigation for NTP amplification is generated, and we can see it in the Flowspec section in the GUI. It uses the destination address, the source port UDP 123, and specific packet size ranges. On the router again, we verify the impact of this new rule. It's programmed and effective, packets are matched and dropped. With show policy map transient type PBR, we can see how the rules are translated locally in the router. On the graphical interface, the two attacks are clearly displayed. We can start the third vector now, the TCP SYN flood. It's not something BGP Flowspec can mitigate directly on the router, because you need an active device to help discriminating the good from the bad SYN packets. That's why the system will behave differently, injecting a /32 BGP route that will divert the traffic to the scrubbing element in our board solution, the TMS. Like we did for the first two attacks, we check IPFix cache, and now we can find TCP/AT entries. We verify the route to the destination. It's now a BGP/32 that took precedence over the static /24. We check the details of our alert ID 3034. The TCP SYN authentication countermeasure is now dropping packets. That confirms the attack has been diverted to the TMS and is mitigated automatically. One last look at the attack against 11.200.0.2. These three attacks vectors are clearly displayed. Let's summarize the test we just performed. A MemCacheD attack has been launched against our victim. The Arbor SP detected it and automatically programmed a BGP Flowspec rule in the NCS 5500. Then we generated an NTP amplification attack, which has been detected and mitigated following the same approach. Finally, we started a TCP flood attack. It has been detected like the two others, but this time the system automatically injected a more specific BGP route to divert the traffic to the scrubbing device, the TMS. And none of this mitigation involved any human participation. To conclude, we demonstrated it's not required to perform any kind of deep packet inspection to mitigate amplification attacks like MemCacheD or NTP. BGP Flowspec on NCS 5500 is the right tool for this job, and it works very well with Arbor products, offering the perfect solution against DDoS attacks. We hope it was informative. Don't hesitate to post comments or questions in the section below. Thanks again for watching, and see you soon in the next video. Hello everybody, we are in San Jose, California, and I'm with Mike today, so I'm very happy to introduce my colleague. Can you please tell us a few words about you and what are you doing in the service provider group?
Yeah. Sure, thanks Nicolas for setting this up. My name is Mike and I'm technical marketing engineer in service provider business unit, and my main focus on programmability, configuration management tools, and application hosting.
So application hosting is indeed what we will talk about today. Before going directly to the problem we try to address, maybe you can tell us a few words about the different options that we have for app hosting.
IOSXR has a vast variety of options to deploy your applications. You can go natively, like a regular Linux application, or you can choose LXC container or Docker, whatever your preference is.
For instance, what we'll present today is a script that you execute directly in native mode. And it's coming from a customer suggestion that wanted to address the lack of BGP Flowspec support on some specific platforms. So you did write a script, and this script is meant to replace or to translate the control plane of BGP Flowspec that we support on all XR platforms into access lists that you will program. That way you will be able to do like a BGP Flowspec Lite implementation just to filter the packets. So can you please tell us a few words about the script and what it is made of?
The script itself relies on Python ZTP. And before going into script details, I need to walk through these concepts. Python ZTP and bar ZTP stands for Python Zero Touch Provisioning, and this is a library available on a box directly. With such library, you can adjust and check the running configuration of the device exactly from the Python code. So you just like import the library itself, and then you start to use the functions which are available for you to play with. My script is utilizing three main libraries. First is XRCMD to apply the command directly on the box. Another one is XRApply, and XRApply used to apply a configuration from a file to the iOS XR device. And the last but not least is for syslog messages. And you should be able to validate all actions happening with the script and its current state through syslog.
Okay, so there is multiple situations where you want to apply the script. For instance, the type of interface you want to apply, whether or not they have already an access list. So if there is no access list on the interface, what will happen?
Okay, it's like the most straightforward situation to deal with, because if no access list applied on the interface and interface up and running, what application will do, it will just create a standard access list and will maintain it. It's very simple because it doesn't interfere with current access list entries. So we fully maintained this access list and apply it when it's required.
And like you said, every time you do a modification, a syslog message is generated locally and remotely.
Yes, or on each action, we just like send a message to syslog.
Can you change the frequency or the cadence of the monitoring of the new BGP Flowspec rules?
Absolutely. Once the script is running, it's Python-based, and we have multiple threads inside the application. And those threads on a specific timer, they just retrieving the configuration from the device. And in particular, they retrieve Flowspec rules applied to this box.
For the case where you do already have an access list on interface, that's something you are handling already on your script?
Yes. The second part is when access list is enabled on the box. And with such approach, you will need to retrieve the existing access list, find the spot where you can apply your Flowspec entries into this access list, and then just like keep it, push the new configuration with updated access list entry. But what's going to happen if your device restarts? A few things worth to mention over here. The first is you can run script with systemd service, and this is just like the regular service you create for the device. That's how you restart script automatically. But you need to tell script how to pick up the entries which was programmed by the script itself. And in order to do it, we leverage the mechanism with comments in access list. We provide the special tag which leveraged by the script, and we are able to utilize that for further access list modification.
Okay, something I should have said, but of course this script is available to the community. You are inviting people to work on it or to provide suggestion?
Yes, please check our article on XR Docs, and we have a pointer in it for GitHub. You can just use git clone or download the archive directly with the script. And it's just like Python script, which you can execute directly on the box.
You can do that on virtual routers too, right?
Yep. We have vagrant version of iOS XR, which is iOS XRV, and you can deploy them directly on your laptop. Each instance will require one virtual CPU and 4 GB of RAM. With such deployment, you can easily run 2 instances, and they would communicate over BGP to introduce rules and apply them through access lists.
Maybe after that, you can run a quick demo also.
Sure. Let's take a look at the demo and process through the application execution.
Let's take a look at the demo. Now we can observe the development environment for the project. On the left sidebar, you can see a list of files. BGPFS2ACL will contain the main logic for the script. All unit tests would be located in flow_test.py, func_lib.py have some specific function, parsing the information about ports or preparing the constructions for our script. Let's switch to the terminal and showcase the demo. We have terminal window with two tabs. On the right side, we have Flowspec server, and on the left side, we have Flowspec client. Both devices are NCS 5501. Let's check what exactly configured on the box. Few class map entries already available on the server. There are around 7 policy applications for drop. IPv4 Flowspec rules already announced to the client. Because we can see Flowspec policy name in the announced rule, we can make a statement that it's locally originated policy. Let's check the output of show BGP summary. Proceed to the client. Interface 18.18.18.30 up and running. There is no access list applied on this interface. No access lists are presented on this device with starting name BGP. Command to execute: show Flowspec IPv4. Bunch of rules already received on the device, and as you can see, there is no policy name. It's just BGP.1. Switching to XR Linux shell when executing bash command. Script already copied to the device, so we do not waste our time in demo. It's available on GitHub. You can go and grab it by yourself. Go to the folder with script. Execute the main file BGPFS2ACL.py in verbose mode and in background. We have multiple components over here. The first script grabs the interface output and the information regarding them. The second step is to check if access list applied over there. It checks the Flowspec outputs, parsing the rules, and building the configuration. Once the configuration is committed, you can see the output in the message, and the message is generated for syslog server. Let's go back to XR CLI. Exit the bash. Show access list starting with name BGP. One of the access lists was created by the script. And we can see the newly created access list with all entries from Flowspec. Script looking for app interfaces where access list is not applied and applying it. Interface 100GG0010 is a good example for it. Let's check its output. Yay! The good thing, the access list already applied to this interface.
Thanks for the demo, Mike. That was really cool. I suppose these same principles can be used for many other ideas.
Yeah, absolutely. Application hosting capabilities give you a lot of use cases where you can deploy your agents directly on the device or implement your own business logic. So the sky is the limit here.
Thank you.
Thank you.
So maybe now you can show us how to install it.
Yeah.
That's good.
Yeah.